All right, so this is the first of maybe 2 or 3 videos for transforming graphs for section 3.5. And again, as we've talked about transformations of graphs in Algebra 2 and Algebra 1, but we always did a specific function in mind, and mostly this chapter right here deals with quadratic functions, but we do get to deal with it in a little bit more advanced way than what we're used to seeing. A lot of times we use this general function notation of just a generic function f of x, and then we get if we add a number on the outside, that tells you that we basically the function has shifted it up. And if we subtract a number on the outside, we shift it down. If I subtract a number on the inside, I shift it right. And where I add a number on the inside with the x, and then I shift it left. And so I just want to remind you about the different transformations. They want us to go through and kind of do the stuff, and then what would it look like, not only in function notation, but also what would it look like graph-wise. Remember, you can always use a graphing calculator to double-check your graph purposes when you do it. So looking at part A here, it says write an equation that shifts the graph f of x, which happens to be x squared, 2 units to the left. Well, 2 units to the left, according to the chart up above, it says I got to basically add a number on the inside. So we're starting off with f of x. Again, this is for A. F of x is equal to x squared. They tell us to add. Actually, we're gonna shift left 2 units. So that means my function notation is going to look like x plus 2 is what's inside the parentheses. So that means I take my x and I just transform this to be an x plus 2 quantity squared. And then, I can leave it like that. That's in vertex form, which we've talked about earlier in the chapter on how to graph from vertex form. If we think about the original function, y is equal to x squared, that is a parabola that is got a vertex at the origin and looks something like that. And so now this one here, so we are shifted to the left. So this one, if we go through and graph it on a calculator, we would see that it is actually shifted 2 units to the left is what ends up happening. And that happens to be that graph. Again, what is the vertex? Well, the vertex is -2, 0. And that is -2, 0 right there is what I have as its vertex. Part B wants us to write an equation that shifts the graph 2 units left and down 3 units. So again, we've already got the 2 units left. So for part B, all we need to do is I want to also do it with it being down 3 units. So again, back on our chart, if we want to move it down, that means we got to put a minus a number at the back. So I'm going to take my function notation. I'm going to add 2 units on the inside. That makes me move to the left 2. But then I want to go down 3, so I put a -3 at the back of the function notation. Now, what would that look like? That would look like that I have an x plus 2 quantity squared still, and then a -3 at the very back is what that's going to look like. And then now that's really in a easily recognizable vertex form here, where the vertex is at -2, -3. And so if we go to draw this graph, we would go over to -2 to the left, down 1, 2, 3. So maybe right about there, 1, 2, 3, -3. And then we would say, okay, our parabola opens like that. Again, that's just a rough sketch. It's not, not an exact one, just a rough sketch of what it looks like. All right. So now here's an application of it in a word problem format that said write a function whose graph is similar to this quadratic function right there, but we want it to be shifted to the right 1,980 units, and then upwards of up 50 units. So we're going to start off with our original problem here. F of x equals 4 times, we can leave it like that. 4 times x squared minus 2 times x plus 1. They tell us we want to go to the right 1980, so that means when it's moving to the right is going to be done on the inside of the problem, so inside the parentheses, so it's x minus 1980, and then I want to take the entire function and move it up 50, so plus 50 on the outside. So then what I do with the function part of it, with the whole quadratic piece, everywhere I see an x, I put an x minus 1980. And then I copy down the original problem, put it wherever I see a, sorry, my bad. I realized my brain was disengaged there. It should be an x minus 1980. X minus 1980. And then plus 1. And then now we have the entire function with the x minus 1980 put in for every x. And then we now have to finish up with a plus 50 at the end. So a plus 50 at the end. They tell us to not worry about simplifying here, so we don't have to multiply stuff out, which is great. I don't have to combine like terms. So that's just substituting it in those places is all at once. If they wanted us to create a new equation, then we're going to go through and simplify and FOIL the first part here, distribute the -2 and combine like terms, and it'll take a while, and it's going to be a big answer. So that's why they asked us not to go ahead and do it. Again, any really polynomial or function we can do transformations on, and so this one asks us to specifically take the equation of a circle, which they happen to give us, where the center of the circle is at 0, 0, and they want us to write an equation that shifts the circle to the right 4 and then up 2. We always have to remember that to the right, when we're going left or right, that's the x values, and up and down is associated with y values. So when we look at our equation of a circle, which is x squared plus y squared equals 9, now I have to go through and say, all right, I need to put, basically for each part here, I need to put a binomial where the x and the y's are. So now since we're going into the binomials, we do the opposite of what it says. Since it says it wants to go to the right 4, that means we do an x minus 4. Since they tell me I want to go up 2, then I have to do a y minus 2. And that way it works out the way we're going. Anytime we're putting the stuff into a parentheses squared, we're making sure we're doing the opposite is what we're doing here. So when we go to graph this, again, the original circle is at the origin. It has a radius of 3. So it's the square root of the number that's on the other side of the problem. So here's my original circle. Sorry, it's supposed to look like a circle. And then now we say, okay, this now circle is now shifted to the right 4 and up 2, so that's where the new vertex is there. So over to the right 4, up 2. So here's, in the orange dot, is where the new radius is. Then I would go out 3 in each direction, and then draw what my circle would look like, kind of in that area.